So here was the original question. You're asked to find the equations of tangent lines to the graph of this function at given points, -1, 2, and 2, 6. But you're supposed to use the limit definition of derivative to find the derivative, and then use that formula to find the slope of the tangent line. Since you're asked to find the slope at 2 points, I would use the general definition of the limit definition of derivative, which is this right here. And here's what it looks like for this particular function. Here is x plus h cubed minus x plus h. That's f of x plus h. Minus f of x. There's f of x. X cubed minus x. And when you have to cube this quantity right here, you could go through the x plus h times x plus h times x plus h, or you could use the binomial theorem or Pascal's triangle. Here's what you get when you cube that binomial. And then when you subtract x plus h, you get minus x minus h. And then when you subtract f of x, you get minus x cubed plus x. And I've canceled out the terms that combine to 0. And each of the terms that remains contains an h. So I can factor out that h. And I get 3x squared plus 3xh plus h squared minus 1 from that term right there. And now as h approaches 0 but not equal to 0, we can cancel out these h's. And then the limit of this numerator as h approaches 0, all these terms go to 0, and we get 3x squared minus 1, which, using the power rule for derivatives, you could calculate in, 2 seconds, 3x squared minus 1, which is what I'm sure you did when you posed this question. You just probably forgot how to do this process right here. Plug in, find f prime of -1 and f prime of 2, and you do get the slopes of these tangent lines. Use point slope to get the equation of the tangent line. There you go. Hope that helped. If you have any questions, post a comment.